Alright, hello guys. In this course, in this rather video, I would like to guide you through recursions, and at the end of this video we're able to handle recursions without any problems. So what a recursion is? In programming languages, or computer science rather, recursion is a special technique that is useful, and this technique applies such that the function makes a call inside of it to the same function. So basically it will look something like this. And here is our example function that I'll call it full, and inside of the function it does another call, maybe a few more calls, and then it returns something. But the main idea is that inside of this function you are calling the same function. This is named recursion. In order to understand this better, I will provide you with an example in math. Hopefully you know what a factorial is, but anyway, I will explain it to you. Let me quickly do this. Boom. So factorial. Factorial is being written like this, and you put the exclamation mark after a number. This is how a factorial is. This is the definition of factorial. It looks like that. So as in this small example, we see a 4 factorial, and 4 factorial equals to 4 multiplied by 3 multiplied by 2 and multiplied by 1. And this is how factorial being calculated. So you can see that every step the multiplication is the same number but one smaller. So 4 multiplied by 3 and 3 is smaller by 1 than 4. 3 multiplied by 2, 2 smaller than 3, um, less than 3 by 1, and so on and so forth. And obviously the answer of this simple equation is 24. And this is how we calculate factorial. I mean, this is pretty much basic stuff you should know from school, but anyway, if you don't, here is the explanation. And let's see how we could make a function that will calculate the factorial. So to define the function, and we'll go with factorial, we'll do some number a inside. This number a is a type of integer, and what we want to do inside. So we can see that every step we do over here, we make our number less by 1 and then do the multiplication again. So we can see that we repeat the same steps in each iteration. And this is exactly how we see that recursion might be useful in the example. And in this example, we could say that we want to return a, so a number that is being passed to a function multiplied by the same function, but with the parameter a minus 1. So what we are doing here is actually a recursion, and we are recurring on the same function. We are calling the same function, but multiplying it with a. And so let me give you a quick explanation how it looks. And this will look something as follows. So 4 we multiplied by a function, so basically 3 factorial. This is how it looks right now. So we take 4 out of 4 factorial and multiply it by 3 factorial. And this is exactly how factorial works, because as you can see, a 3 factorial, let me do it another so, a 3 factorial will look as follows. 3 factorial equals to 3 multiplied by 2 and multiplied by 1. And as you can see, 4 factorial is basically 4 multiplied by 3 factorial. And we can use this fact to build a recursion. So over here, what we are doing, we actually doing this exact step where we are multiplying 4 by 3 factorial. So we are taking current number and we are multiplying it by this, calling the same function, but with an argument that is one less than the given one. So the following function will already try to compute our factorial, but we'll still have a huge problem. You can pause the video and think what's the problem we will encounter, and I'll explain it in a few seconds. Alright, so the following problem can be seen somewhere here or here where we actually calculate the factorial. We can see that at the end we're not like going and basically incrementing the value by 1 forever. We are stopping at 1 always, and this is what our code is still missing here. And this code needs some base case. What's a base case is? So for example, for factorial, base case will be something like, for example, 1. Oops, sorry. So 1 factorial is a base case because 1 factorial equals just 1. And another base case could be 0 factorial that equals to also to a 1. Those two are base cases where we don't do any additional steps. Just as calculation of 3 factorial or 4 factorial, we were doing additional steps of multiplying it by something. But 1 factorial and 0 factorial, we just know that they equal 1. And in order to implement it in our recursion, we have to add a few if statements at the start. So if a equals to 0 or a equals to 1, we will return 1. This gives us a base case. So if at some point the function looks at the parameter that is being given and it sees that it's 0 or 1, it doesn't go to the recursion, but it rather goes to the base case, a equals 0, a equals 1, and simply returns 1. This allows us to start the recursion. So, I mean, to stop the recursion. And this way we will be able to easily compute the factorial. Let's run the following code like that. Print factorial. Let's put a 4 here and boom, it's 24. Just as we have done here. Hope this small explanation helps you to understand factorials, and you can find the following notebook. I will put it somewhere, I think, in the description, and hope it helps. See you, man.